Okay, hello, I am one. So we are just getting into chapter 9, and I'm not sure what kind of background you all have with inequalities. So I'm just going to demonstrate how to do two problems from the homework. I'll do number 6 and then 7C. And if you have already figured this out on your own, you can disregard this. This is just in case you got a little bit confused on following with CPM. So basically, the strategy for solving inequalities is exactly the same as solving equations, except instead of finding the single value that makes it true, what you're doing is finding all of the values that make the inequality true, because there's infinite numbers, there's a whole range of numbers that will make it true. And when you solve the inequality like an equation, what you're doing is finding the boundary point. And the boundary point will either be an open or closed circle, meaning it either includes the point or it goes up until the point, but not including the point. And so there's one other little twist that number 7 will have also, and I'll get to that in a minute. So number 6, following our equation strategy, subtract 1 from both sides, and now you have 3x is less than 6. Divide both sides by 3. And you have x is less than 2. So what we're saying is any number that's less than 2 will make that original inequality true. And because that's a whole range of numbers, it's often useful to show the solutions to this inequality on a number line. And the way I draw a number line is just put the important points. So 0 is always a useful reference point, and then in this case we have the number 2 because that's our boundary point. It's a less than symbol, not including 2, so we're going to emphasize this circle, and we're looking for all values smaller than 2, and smaller is to the left, and so I just kind of shade it in, fill in the arrow, and so these are two different representations of the solution to the inequality. On question 7c, the twist on this is that you have 5 minus h. So the variable h is actually negative as it exists right now. And you don't want to have it end up being negative. So I'll show you what I mean. If we subtract 5 from both sides, you're left with negative h is greater than or equal to negative 1. Well, that's not very useful for us. This means the opposite of h is greater than or equal to negative 1. We don't want to know what the opposite of h is greater than or equal to. We want to know what h is equal to. And so the strategy we might use for solving an equation is to multiply both sides by negative 1. That would eliminate the negative. Now it turns out what happens here when you do this is it flip-flops the relationship between the variable and its solution. So when you do this, you're also going to change the direction of the inequality symbol. So we'll end up with h is greater than or equal to negative 1. I'll show you another way that you could represent this. If you have negative h is greater than or equal to negative 1, another thing you can do is move the wait, hopefully you caught that. I didn't actually change the direction there. So this should have been less than or equal to 1. Okay, you can all stop shouting at me for having messed that up. So going back, another way to represent this is you could actually move this h to the other side and this 1 to the other side, and it would become h related to 1. And these two things are the same, just read backwards. H is less than or equal to negative 1 here. And then if you read it from this way, h is less than or equal to 1. So you get the same result, but just remember, anytime you multiply both sides of an inequality, or if you divide both sides by an inequality by a negative number, you're going to reverse the direction of the inequality symbol. You'll see this more often coming up, so don't worry if that's a little confusing, but I just wanted to point out two things that might be confusing to you. and let me know if you have any other questions.